Hi everyone, my name is Wei-Ren and I'm from the University of Sydney. My topic today is formulation and characterization of spray-dry budesonide in organic solvent suspensions for aerosol delivery to the lungs. So I'll begin by bringing you in on the brief background of spray dryer to the advantage of spray drying of suspension from organic solvent, and then I'll go on to discuss in more depth the implications of the data in the file in front of you. As most of you know, for spray drying potent drugs such as inhaled corticosteroid and beta-2 agonist, we often add excipient in the liquid phase to improve the resultant drug powder flowability and dose metering. And lactose is one of the most used excipient for dry powder inhaler because it's physically stable and chemically compatible with many drugs. However, due to rapid drying process, spray jar lactose particles are usually amorphous and unstable, and once amorphous lactose absorbs enough moisture, it will recrystallize and make particle properties change. So in order to overcome this problem, we were thinking, how if we dissolve hydrophobic drug in an organic solvent and then add lactose crystal in it? As lactose can't dissolve in an organic solvent, lactose particle will suspend in the solvent, and its crystallinity will remain the same even after spray drying. So we can avoid producing amorphous lactose. Besides, there is another potential advantage for the suspension formulation. After the droplet dry out, the hydrophobic drug can cover on the lactose particle, and it can serve as a function of protection layer to prevent lactose from moisture. So in this study, we test if this new powder formulation obtained from suspension can be more stable and have better powder dispersion performance than the solution formulation. In this study, we use budesonide as a model drug. For solution formulation, we dissolve both lactose and budesonide in 50-50 IPA isopropyl alcohol and water co-solvent. As for the suspension formulation, we dissolve budesonide in IPA first, and then suspend lactose crystal in the IPA solvent. And both liquid feed had the drug lactose mass ratio of 0.068 to produce powder containing 320 micrograms of budesonide in 5 milligrams of powder. And this drug dose is the same as the drug dose in the commercial product. Besides, both liquid feeds were spray dried using Bilkey 290 mini spray dryer, and this table demonstrates the spray drying parameter for these two formulations. And the reason that we use different operating parameters to spray dry different liquid feeds is because we wanted to produce powder formulation with a similar initial particle size distribution. And the volumetric median diameter of both formulation was around 4 micron and span was around 2. After we produce these two powders, we store these powders at 25 degrees Celsius and 60% RH for 3 months. And at different time points, we test powder crystallinity, morphology, particle size, and powder dispersion performance. Let's move on and look at the results. This graph shows the powder crystallinity before and after storage at different time points. The solution formulation was initially amorphous, but it recrystallized and started to show peaks in XRD pattern after 1 week storage. In contrast, the suspension formulation only shows the peaks of alpha lactose monohydrate, which is one of crystalline forms of lactose. And the XRD pattern remained the same throughout 3-month storage. Besides, we found no budesonide-related peaks in both formulations. This was due to low drug content in these two formulations. And next, for solution formulation, The particle was initially spherical. However, it recrystallized and formed cake after 7 days storage. As for the suspension formulation, it comprised both prismatic lactose particle as well as small and spherical particles. It's because during spray drying, some droplets could contain no lactose particles, and those droplets containing no lactose particles are so-called empty droplets. And after those empty droplets dry out, it will form drug-only and spherical particle. However, even though suspension formulation contain no amorphous lactose, it still shows solid bridges after 1 month storage. And these solid bridges were due to budesonide recrystallization, which means even though budesonide is hydrophobic drug, storing at this certain environments still make it recrystallize. And this graph shows the particle size before and after storage at different time points. The particle size of solution formulation surged from 4 micrometer to 25 micrometer within a week. In contrast, the particle size of suspension formulation remained less than 5 micron throughout 3 months, even though we found some solid bridges between budesonide. The last is the powder dispersion performance. The y-axis at the left is fine particle fraction, and the y-axis at the right is mass median aerodynamic diameter. The fine particle fraction and the FPF of suspension formulation was much higher than the FPF of solution formulation. It's because the solution formulation was mainly amorphous, and it is known that amorphous powder possess high surface energy that will hinder particle to deagglomerate during dispersion. However, even though the suspension formulation had superior dispersion performance at the beginning, it still deteriorated gradually throughout 3 months storage. And at this stage, I would like to run over the main point of this study. First, the solution formulation was highly unstable and recrystallized after 1 week storage. Second, the suspension formulation shows slower changes in both particle size and morphology. Overall, the suspension formulation could reduce moisture-induced deterioration and demonstrate superior stability and dispersion performance compared to the solution formulation. And I would like to thank my supervisor, Hawking Chen, and co-supervisor, Philip Go, and all the members from Advanced Drug Delivery Group for their support. And this is my presentation today. Hope you enjoy. Thank you for your attention.